Hello, everybody. So we're going to discuss the 5th chapter of the book, Efficient Input Outputs. It is about reading and writing data in R. And so what I would like to discuss with you is a general principle in reproducible data management, and then we go to the REU package and discuss about plain text formats and binary formats. And then I added a bit of an extension on the arrow package, which is not in the book, simply because at the time of writing of the book, the package was not there yet, or not in that state. And finally, we have some parts about getting data, which were the last paragraphs of the chapter. Okay. So a general principle, which I think is very important indeed, and is also stressed in the book, is that you should never modify raw data files. I'm not sure how you look towards this subject, but I strongly believe that it's important not to do that in order to keep the raw data files always as pristine as possible. In the book, they also recommend to not change the file name in order to testify the origin or the provenance of the file. But well, I think it's more important personally to document the provenance of a file. I think the name doesn't matter that much, and you can have very odd names, I think, in raw data files. I don't know if there are any comments on that.
I agree.
Okay. Then the REU package. Honestly, I haven't used it at all before. So it's a Swiss Army knife for data input outputs, and central functions are the import and the export function, and they are wrappers for various functions in other packages, which they call depending on the format of the file that they get in, and it's based on the file extension actually, which you can override by a format argument. And many formats are supported, including Google Sheets, Parquet files, JSON files, etc. So it's probably easy for a whole bunch of users to use this package, because it means you don't have to think about which function would I use for this or that file. There is a vignette with the list of file formats that are supported, so it's quite extensive. There's also in that vignette there's a convert function discussed as well. So it's not in the book, I think, but the convert function just converts the file formats without explicitly importing and exporting. Still, I don't know whether it's perhaps does import and export actually behind the screens, but I don't know that. So next we go to the plain text formats, unless somebody wants to add a comment here. So plain text formats, main formats are CSV formats and delimited formats, and you can open them or import them with various functions. Base R with the utils package, which is always loaded, can read them with these functions. But then you also have read R functions and data table function, and they are expected to have an increased performance. So the data table function has the best performance of these. Still, it does depend on the size of the file and on the number of columns, etc. I could perhaps jump to the book and see there's a benchmark. Oh, oops, which they did, and it's illustrated in this graph. And the base functions with increasing file size are increasingly slower than the data table function. So this is a relative time, which is in the y-axis. So the data table, it's relative to the data table import function, so the fread function that is. So the base is increasingly slower, while the read CSV function from readr does approach the data table function very well for larger files. So that is striking effect. And here we also have some effect of the number of columns. So which also with increasing number of columns, the difference between readr and data table is smaller. So that was an interesting thing to see. I wondered whether this would be different on my computer, which may be a little faster because of the several years in between, but I have given up to run the benchmark because it takes very, very long. So there's, I think, perhaps, if I remember well, a loop of 12,000 times reading a file. So it took way too long. Anyway. So for these functions, so there's the effect of the file size, there's the effect of the columns. Also interesting that you can pre-select columns in the case of the fread function, and also the read CSV. I think actually they may all be able to do this. Certainly the base R function and the data table function is able to do so, and it does increase the speed of reading the file. On the other hand, I think that's next. Yes, readr and data table make a guess about the column type. So that's another thing. So if you pre-specify column types, it also works faster. Otherwise, readr and data table look at the first 1,000 rows and make a guess based on that. But still, it's possible, and they illustrate in the book with an example, that the first 1,000 rows are not representative. They can be just missing value for one column. And it appears to have changed in the meantime, the behavior of read CSV from the readr package. That is to say that the column was formerly set as logical if all values were missing, while now it is set as character, which actually makes the illustration in the book obsolete, because in the book they demonstrate a clash because there are actual character values further down in the data set. Finally, that's a looking ahead to the arrow package. Also, the arrow package has specific functions for plain text files. So it can read CSV, TSV, other delimited files, and the JSON file format. So if there are no comments, but you can certainly interrupt, we can proceed to the binary formats. Any comments? So, okay.
Wait, Jim said in the chat, he just said JSON, any comments? I mean, nothing in particular, but it is like the web, or one of the main web formats. So it's something that it's good to be familiar with JSON. I don't don't know if anyone else has any thoughts.
Okay, I see. I was not looking at the chat.
Yep.
Mm,
It's
yeah. Data.table is the package
Yeah.
indeed.
Yep.
Yeah, the magic in data.table, I don't know actually. So I've not been using data table. I know it is somehow more efficient, but how it's effectively is doing that, I don't know. Perhaps somebody else can comment on that.
It's mostly just that data table is pretty much all C in the background, and C is always faster. But depending on what you're doing, I've had some pretty good success with readr, which builds off of vroom. And I used to be like an fread from data table, like I was the diehard, and now I've just been using read_CSV. And it's especially nice with the little, like, when you read something in, it gives you a little output with information on what you just read in. So
Yeah, definitely. Since this book was written, readr got the under the hood. It got pretty much completely rewritten, and that's what vroom is, the package that's like behind readr now for the reading, and it was written to be very fast. And in certain situations, it's now faster than data table. So yeah.
Interesting, yeah, right. Okay. All right, something to read.
Yeah.
Okay, thanks. So the binary formats, so compared to the plain text formats, they are more efficient for reading and writing in terms of the time, and also in terms of file sizes. On the other hand, contrary to the plain text files, they're not human readable, so because they're binary, and also that may be language specific, so which may also make it less portable than, for example, a plain text file, which is just follows some standard. But that differs among binary formats actually. So here you have several formats. The first three are discussed in the book, and the last one, the Parquet file, I have added. So the first two are, let's say, native R binary formats, so which can be provided by R specifically, and also normally only read back in by R. So and you have the R data format and RDS formats, and so you have the save and load functions to create and load an R data file. So an R data file it does not have to, but it can contain multiple objects, and it includes their names. So if you load an R data object, the object names are just available as they were available at the moment that you saved those objects. And in the book, they disrecommend using this because it has the risk, for example, of overwriting other already existing object names. So it offers a bit less control. On the other hand, it can be convenient if you want to load multiple objects, for example. On the other hand, they do recommend using the RDS file because that is used for a single R object, and you can actually use the read RDS function as you would use the read CSV function, for example. So you just refer the file, and you still have to assign it to an object name, or it will just print if you don't do that. Also, those file formats, they are smaller. So you have a smaller file size than CSV. So those are some advantages. Then the feather package. So they say that it was developed as a collaboration between R and Python to create a more language agnostic format for storing data frames, which is fast and light. And the Feather package at that time, it was written by Hadley Wickham, and so the write Feather, the read Feather functions, they return, it still works, you can install Feather, it returns a tibble. In the meantime, the arrow package has been developed, and the write Feather and the read Feather functions have been rewritten and incorporated as well in the arrow package. So that's the more recent versions of these functions that you have there. And as far as I have understood from vignettes and other sources, the arrow and the feather formats are regarded as synonyms. Then, and that is new for the arrow package, which uses a C++ library underneath the Apache Arrow library, which is not only ported to R but also to various other languages, and which just like for Feather, it's light, it's fast, and it's language agnostic. So the Parquet file is what is used there. So you can use write Parquet, read Parquet. You also have write dataset and open dataset, which I will come to in a moment. Let's have a look. So both file formats, so the arrow file format and the Parquet file formats, and they are column based. So they work a little different. And I was at a certain moment wondering when you should use which, and what they say in a certain blog, it is already dated, but from more recent sources I found, I think this is still reasonable, that the Parquet balances page efficiency with deserialization cost. So it is it has a more compressed, it is more compressed than Feather. That's actually the essence. And Feather is a little, the file format or the file size is a bit little larger, but it will also read faster. But the differences, the differences are there, but both are still way faster than the other options that we have seen already. So it's all very relative, of course, and it will also depend on your specific use case, which works best. It's really meant for very large files in the sense of gigabytes, where you would really want to use this. But you can also use this for small files. So the read Parquet, you can use it to load a Parquet file, and it will return a data frame. And just as in the previous functions that we saw in the other packages, you can also pre-select columns. You can also return a more low-level object, which is the arrow table object, which you can do with setting as data frame equal to false. And that is also a bonus compared to, for example, CSV and other text formats. The object attributes are preserved when writing to Parquet or arrow feather files, even though these are not R specific. So the R binary file formats also have that feature, but this is also guaranteed by Parquet format. Another interesting feature is that it can handle in-memory data, but also on-disk data that are larger than memory. So that means that it can make a connection to the on-disk data and apparently somehow approach it as if it were a database. In some respect, it is similar. Another interesting aspect there is that yeah, the data can be exchanged with other applications without copying. So it means that you can pass, for example, data from R to Python, or perhaps another language or application, and just point to the same memory block or the same data file without needing to export and import by writing to disk, for example, which is a huge, can be a huge efficiency gain. Some more things on Arrow. So perhaps you can click on the link and also show that there are quite some vignettes in the package about, among others, reading and writing data files, which I have been looking at for this, but also working with multi-file datasets using cloud storage, and so it's also compatible with the cloud. So it's very interesting, and there is a get started and really accessible get started vignette as well. So there you can see, for example, how an arrow table looks like, and such. So let's go back. So you also have, besides read parquet, the write parquet, you also have the open dataset function, which is specifically tailored to the larger than memory files on disks, and it can make a connection to those to this or those files. So it will return another object type. It's called an arrow dataset, and it's actually a pointer. And you can build on top of it, just like with the dbplyr package, using dplyr verbs. So you can do filter, arrange, etc. And when you execute that, you still only are building some sort of query. It's only when you pipe it to collect that it will actually compute the query and extract the data that you need. So that's an interesting approach to coping with large data sets. And also good to know is that you can also do this for large CSV files. So if you have a CSV file of several gigabytes, you can also use the Arrow open datasets instead of even the CSV reading function of Arrow, just to avoid needing to read it all into memory. There's also a chapter in the R for Data Science book on Arrow, and I have a citation here. Well, yeah, here they discuss about, would you use Parquet or would you use a database to store large data set? And well, they say it's hard to predict, so you should try and see what's best in your case. Another thing which is interesting, for a data set, you can generate a multi-file data set. So you can partition larger files. For example, here you start with a CSV file or CSV. It's a data frame here which has been written, and it's you pass group by, you make it a grouped data frame, and then you can use a write dataset from the Arrow package to split it into multiple Parquet files, which you can then access with open datasets again, and then it will work more efficiently, especially if you group by some often used variable, which would cause the queries not needing to look into all the files afterwards. You can even convert the dataset to a DuckDB format. All right.
I want to pause there. So the first part was interesting, and I'm not sure how different it is. So I'm currently working on a project with Spark, and that also essentially uses the same concept. It runs dbplyr under the hood. So whatever I write with my dplyr queries is actually translated into a SQL query, I think via dbplyr, and same concept that, it's not actually running. It doesn't bring the data into the memory as long as I'm working on a Spark object. And then when I do collect, it brings it in. And can you go to the previous slide?
Yes.
Arrow 2. This concept though was very new to me. I'm not sure how this works. So that group, when you said, doing this will increase the performance a lot, what really, do you know, like what is driving that improvement in performance? Like, it sounded like something, in the database world, they used to say indexing and partitioning, but how does that, how does grouping here lead to the improvement performance? And is there a similar analogy for Spark? Because that, improving the speed of reading and writing there would be very helpful in my case right now.
I can tackle that one. So Spark and Arrow, when you do group by, it's using your group by variable to partition. But then on the file side, all a partition is just a folder with a bunch of CSVs. So if you group by checkout year, you would have a folder for, let's say, 2020, and that would have all of your data from Seattle CSV for 2020. And depending on how big each file is, you might have more or less files in that 2020 folder. And then if you had 2021, that would be another folder. But both of these year folders would be in a parent folder called Seattle CSV or whatever your data set name was. And so that's why part of what gives it such a speed up when, especially filtering by those grouped by or partitioned variables, because it doesn't have to search through all of the data. It already knows, hey, all of my 2020 data is just in this 2020 folder.
But it is still applying, for example, you said filter, it is still going to apply the filter on all the, smaller data sets.
Yeah.
It only gives you a speed increase if you're using that variable. Let's say you're saying filter, checkout year equal 2022. Then you would get a huge speed increase because it doesn't have to look at any other file. It acts like it's going to look at the other files, but then when it gets to that step, it changes what it actually does on disk. And it's okay, I never have to open those other files because I only want the ones that are 2022 and I know where those are.
Oh, okay. That makes sense because, for example, if I have 5 years data and we are grouping by this 1 year, so I'm, reducing my data input to at least maybe around 20%. And that's why the speeding, because now we're looking at a smaller chunk of it, which is okay. So can you repeat what you said? Only when you're using that. So if, for example, if I have to filter, if I would group by that, whatever column that is of interest. If I group by that and then I say filter and then I ungroup,
I'm saying if later. So if you do that and you write it, and then you come back later and you're okay, I want everything that was on a Monday. Now it has to look in all of those folders because you're not using the checkout year anymore. And so you're not going to get anything out of it. Now, if you still are and I want to group it by year, it's okay, cool. I know how to do that. I've got that. So as long as you're using that variable, and usually what you would do is something like this, where probably you're going to be grouping by year pretty much all the time in whatever you're working with. And so split that up, and then it only has to do it once. It might be, I don't know how long it takes to do this step. It might take a while, but then once it's done, it's done. It has done that step. and it's kind of it's like it's caching that part of the work.
So, okay, so I work with, I mean, the data, we do a lot of aggregation by X, column X, Y, Z, and month. So then
Yep.
it is going to create those many smaller chunks, and my filter tends to be more than this month value. So it's 1 to 100 months since time X in the history. So now when I say that or not even 100, maybe let's say 10 or 12. So then, so if I say, okay, more than 3, would that still be any more efficient?
So long as you, so I think the group by here is actually a little misleading because you're not writing a grouped data set.
Mm.
You're partitioning the your folder structure is set up by that grouped variable. So like if you were reading checkout year back in and you wanted to know if checkout year was greater than 2020, it would still help a lot because now you just have to check like the 2020 and up folders. And then if you group by, if you partition by multiple variables, I believe it will just start creating a nested folder structure for you. So then if you said checkout, you don't care what the checkout year is, but you care about, let's say like the month, then you would still have a bit of a speed up because you still have to check every year. You only need to check specific months.
Okay. But I think so, just to sort of get it right in my head, so when you're doing a group by in this situation, and it doesn't necessarily have to be a writing situation, it can be any operation that we're performing, right? So group by is not really a dplyr group by.
No. So like at one point I needed to just chunk up my data at work, and it didn't really make sense to chunk it by any inherent variable. So I just created a new column that was like every like 300 rows or so and just chunked it by that.
Okay.
So it was like this arbitrary value that just helped me read and write the data much faster than I would have if I had to read in and write out the whole table every time.
Interesting. And then this group by, so again, so just trying to get this right. So this group by that we're looking at in this code right now, is this, in this particular case, is this coming from arrow? So is this arrow : group by, or is this still dplyr : group by?
It's complicated. It's the same group by, but it's the method that's getting dispatched when you actually do something with the group. So it's applying that group. So I guess, I mean, it's the same group by effectively, but right data set is saying, okay, with that group, here's what I'm going to do. And that's a totally different thing than what dplyr does. So but really like with DB,
if it's different, how do I identify, or how would R know it's different?
It's not different in that way. It's not different in any way that you have to care about.
Because right now, the project we work on, we explicitly give the namespaces for every function that we write.
You would be fine because the arrow group by is just the dplyr group by. It's the methods that are different. So arrow I'm pretty sure re-exports group by.
Okay, because some things are most of the dplyr codes work in Sparkler, but some things are very nitpicky. And so, for example, full join can act as a self join if you do by is equal to character, but that, probably that's also fine. But keep is equal to true is an option that works in a full join from dplyr, but not with the Sparkler one.
So
go ahead, Gus, because I know nothing about Sparkler.
What John is trying to say is like that group by is still dplyr's group by, but it returns, if you were to run class after grouping, it would return, I think it says like grouped table or something as one of the classes. So then write data set has a grouped table like method
Mhm.
that is specific for those grouped tables. Whereas if you used an ungrouped, then a different version of write data set would pick it up. And so that's what's happening with Sparkly R, is it's saying, hey, we're actually taking in a Spark table right now. We're going to use this other version of full join. And so you can't really tell because it looks the same, but then Sparkly R will pick it up, do what it needs to do. And then if there's anything left over, it will pass it off to dplyr to finish. But
Oh.
Sparkly R gets confusing because it's not a direct interface with Spark, like PySpark or Spark R.
Mhm.
Sparkly R essentially just creates SQL queries and then runs the queries against Spark. And so that's why there's a lot of like weird little nitpicky things you have to do differently, because it's not that Sparkly R can't do it, it's SQL can't do it. And so there's no like direct way for Sparkly R to make it happen.
Yeah. Okay. Cool. I think this is helpful. Thank you so much.
For sure.
Yeah, the example with the Seattle CSV, it's actually from the book, so from the R for Data Science book. So it's actually here, and the Seattle CSV, it appears to in itself already to be in data set, which they create here, which you can see here, file system data set with one CSV file. And then, so it's already not loaded in memory. And here they demonstrate that you can indeed use such data sets with the dplyr verbs and collect the results. And then they go further to look at the Parquet format, and here is the chunk that I had taken in the slide. So they take the data set again, which points to the CSV, but which is not loaded in memory. They add the group by, which is actually already then executed as a query, I presume, and also then this works with when it is followed by write data set and partition it over multiple Parquet files. And here you can see the files that were created. So you have indeed folders which are named as variable equal to value, and then there's a Parquet file within, which in this case is more or less in the same order of magnitude. All right, and then they open this dataset. So the PQ path here is effectively the folder, so the directory where these Parquet files live, and these subdirectories. So here they open, and then they make a query which looks like this if you print it, and then they collect the results. So let's go further. Yeah, I made a very small benchmark because I was wondering, because not everything is in the book on efficient R programming. So here we can see I've well, let's just jump to the bottom. I made some largish file, but it's still not very large. So the file size of the CSV is 112 megabytes, and in the case of the corresponding Parquet file is 46 megabytes, which nicely demonstrates that it's reduced file size. And then reading it 20 times with various functions, so base R, read CSV from read R, every from the data table package, then read CSV from the arrow package and read Parquet. And then we can see how well they compare. So the base R function is really slow compared to all the others, and then read R is also still less efficient than data table and then the arrow function. So the arrow function for read CSV here more or less resembles the data table package, and read parquet file is still much faster. Of course, this is all case dependent. This is depending on the choice of the specific data frame, its size, which I have chosen. It's also nice to see that the allocated memory in the case of arrow is smaller than in the case of data table here. So I'm not sure if anyone has different experience with these. To me, most of these functions are still new and advanced. I'm just used at using the read R functions from the tidyverse in effect. All right. Then the last part, that's about getting data. So there's download file from the base, from base R, but you also have more recent functions, one of which is curl download from curl and also multi-download from curl, which are, I think, not cited in the book because probably they are also more recent. There's a reference to another, perhaps an older curl package for R, but I believe this is the more current one. And I'm not sure, I think I've read it in a vignette or in a, perhaps in the Art of Data Science book. I can't remember, but it was advised to also use curl multi-download in case of single large files because it is more robust. So it can resume the download if it is interrupted. And you can find more packages at ROPSI and the Cron task view, which is recommended in the book. And then that's the last slide. It's also discussed how to access R objects that are distributed by an R package. Either these are available as R objects, and you can enlist them with the data function just without referring a specific object, or you can load them, and you can load multiple of them at once using the same data function referring to the object names. This more or less reminds of the load function actually of our data files because they are named and present in your namespace after calling this function. So besides R objects, raw data files can also be distributed by the R package, and typically they are, but not always, but typically they are in the X-data directory of the installed R package. And then you can list what is in there by using the list files function. So the system.file function returns the absolute path, file path of the X-data directory for a specific package. And once you have that full path, you can list the files which are present there. Okay, I'm through the slides. I'm not sure, perhaps there are still more comments or remarks. Sorry.
Yeah, thank you for this. I mean, for Parquet, I never do that. Actually, I have a data size of 13 GB and I have a PC with RAM of 16 GB. So maybe this will help me.
Yeah, I can
I
believe
never
that.
knew that. Thank you.
There's also, I don't think anyone really uses it anymore, but there's disk frames, which sort of let you operate on the whole thing on disk. But I think since the introduction of Feather and Arrow and all that, I've never actually seen anyone use it. So it does exist.
It's the name of a package.
Yeah, I think it was just disk.frame. But
Here, yes.
yeah. So I don't know really. I guess it was updated recently, but
Yes.
that's oh, I guess it looks like it's importing Arrow now, so it might be doing something with Arrow behind the scenes for you.
Mhm. It's interesting. Yeah.
It's recently published, 7 April.
Oh, here it is that it has been soft deprecated in favor of Arrow.
I guess that's the answer to that.
Yeah. Okay. All right.
All right. Well, we've got a discussion in the channel about the next couple of weeks. We're gonna give me a week to figure out what we're doing in the kind of missing chapter. And so next week we're skipping ahead by 1 chapter. And let me load up the spreadsheet so I can talk a little bit more intelligently. So yeah, next week we'll be doing chapter 7, which is efficient optimization. And then the following week we'll do a replacement for chapter 6, which is going to talk, I think it's going to end up mostly being about probably target. But I have to I want to read the chapter and see what was there and make sure I'm kind of replacing what was there with how I would do it today. I don't know. I'm going to do a little bit of an overview of wrangling packages, basically, I think. And yeah, so that's the next 2 weeks. I think, let's see, we've got chapter 8 in 3 weeks is open, and everything else is spoken for, which is awesome. So yeah, if no one has anything else, then I will see everyone in the channel and see you here next week. Bye.
Thank you, Floris.